Okay, guys, hopefully I'm recording here. Let me show you what's going to happen. What I've got Bailey's iPad paired to the screen here. I'm doing an on-capture screen recording, and this is going to allow me to do stuff like this. Okay, so we'll be going back and forth from that, obviously, to the quiz, and then down here I've got the TI-84 emulator software. So let's do it. Let's get this done. So. Guys, this is set up, again, I told you in class these were copy and pasted directly from my final exam in the spring of 2013. So often we're going to get problems like this where we're going to have information and use it for multiple questions. So that's what we have here. We've got the first two questions that are, this information. Now, when I read this, the first thing I see is, results from a few years ago. So this indicates the claim is 23.3 years. Right off the bat, the way the wording in this problem, we see the population standard deviation is 4.8. And if we run on down, before we read the rest of the problem, before we come down to question number 1, which is the value of sigma, which is the population standard deviation, well, gang, that's an easy one. That's just A. It's given to us directly in the problem. Now, when we come on down, it's important to note that it says it is suspected that men today wait to get married. Well, if they're waiting to get married, that clearly indicates that we're expecting, or at least we're wanting to test, that the mean at which men get married is actually higher today than it was years ago. So, that indicates greater than, so we'll keep that in mind when we set up the calculator. Now, what I've done is just gone through, and let's again, this is mu0. This is what's going to go in the null hypothesis. This is clearly sigma, as indicated by the answer in number 1. The 40 is clearly our sample size n, and the 24.2 is our x bar, and sx, the sample standard deviation, is 5.1. So in working number 2, I'm going to go back to the air server, and you can see that what I did here is I went ahead and wrote this information down. Now in this situation we have a where we're given both standard deviations, and guys, as I've pointed out in class numerous times, if we have both of these, sigma will trump the standard deviation from the sample. So, first thing I want to do is set up the null and alternative hypothesis. And we have this situation here. Okay, so that's the first two steps. The next thing I want to do is calculate my test statistic and p-value, and I'm going to do that information from the calculator. So, guys, what I would do here is I would go to stat, I would go over to test, and because the population standard deviation is given, and I'm actually testing a claim about an average, I should know by now that I use a z-test. All right, first thing is, do we have the numbers or do we have the stat? Well, we got the statistical results. We don't have the numbers typed in any list. Come down to mu0, which is 23.3. You can see I've already got some of this information in. The population standard deviation is 4.8. Sample mean is 24.2. Sample size is 40. And guys, come down and select the inequality, which is greater than in this problem. Now, what some of you are doing, I noticed this in class, you're getting down to this point, and let's say it was to be set at not equal to. You're hovering that kind of icon over it, but you're not selecting it. Guys, you've got to select the right one. You've actually got to hit enter once it's highlighted. If you get that set wrong, you're just going to get the wrong answer. You get the wrong p-value, and that's not what we're trying to do here. So anyway, guys, go ahead and calculate. We, in this problem, it's kind of unique because all we want is the p-value. So We go back to the answers. 0.1178 is what we're looking for. And it turns out that 0.1178 is located at A. So A is the answer. Now, number 3, we wish to calculate the 74% confidence interval for an unknown population proportion. What's the corresponding z-value? Well, guys, this is just like before. Let's go back and, nothing's different. It's going to work just exactly like it did when we did the 95%. So we're going to draw our normal distribution. Just like in class, we're going to put the 74% in the middle, because the confidence interval seeks to find the middle, 95%, 96.8%, 99%, whatever it may be. In this case, of course, it's 74%. Now, the first question I always ask you is how much is missing? So 26% is missing. Need to divide that by 2. So we have 13%. So guys, on each tail, we need to put 13%. So we should know by now that to find this one, we're going to use inverse norm. 0.13, comma 0, comma 1. All right, so let's go back to the calculator. Let's do that. We should be pros at finding these keys by now. So let's go to inverse norm. We need 0.13, comma 0, comma 1. Close it up. And we get negative 1.12. Well, the way this rounds here, it's going to be negative 1.13. So, now obviously, guys, if we were looking at the other side, it would be positive 1.13. So we got a plus and minus 1.13. So we're coming and checking that out, and the answer that's provided is B. So that's the correct answer. All right, number 4 is a little tougher because you've really kind of be aware of what's going on here. First thing's pretty obvious. We have a situation where we're testing a set of hypotheses, and we've got the test statistic to be t equal negative 1.84. So I'm going to go ahead and write this down on the iPad because I'm going to do all the calculations over there. So our t value is negative 1.84, and our sample size is equal to 40. Right? Right. All right, so gang, let me get you back over here. This is what I wrote down. Now, first thing I have to look at is what distribution do I have? If this was a z, and it's not, I'd use the z distribution, mean 0, standard deviation 1. But I have a t distribution. So what I have here is I have the t distribution. Looks like a normal distribution, but we're looking at the specific one that has degrees of freedom 39. Now, because I'm doing a left tail test, I'm putting all of the rejection region in the left tail. So all of my calculations for the p-value have to happen in the left tail. What we do next is we come in, let me get a little bit fancy here. And choose maybe a different color. Let's choose some Kentucky blue. How about that? So come in here, and the p-value. Oh, that was just lovely. Let's choose yellow. Maybe that shows up better. The p-value the test statistic that we have here. The p-value is going to be the area to the left in the tail. So I need to find the area from negative infinity all the way up to negative 1.84 using the t distribution, degrees of freedom 39. Well, hopefully we know by now that to do that, the easiest way is to use the calculator. You could also use calculus, but we don't want to go there. So gang, let's go second function distribution. And I need to come down to TCDF. And I need to go negative infinity. Up to negative 1.84. And remember, these distributions are a function of degrees of freedom, so we have 39. And then we have to stop and think, do we need to multiply this by 2? Always keep on the agenda, do we, or on your radar, I'm sorry. Do we multiply by 2? Well, we never multiply by 2 in a one-tailed test. And greater than and less than are one-tailed tests. So guys, I just hit enter. I hit enter. So I'm looking at 0.037. So I'm going to go back and find the answer that's closest to 0.037. And that obviously clearly is part B, or is question B. Question B, answer B. Come on, Doug. Not enough coffee yet. All right, gang, let's go on to number 5. So what I'm going to do is I'm going to get the problem ready. So I'm going to write this on the iPad so when we get over there. So essentially we have the same thing. We're testing mean is equal to 8 versus mean not equal to 8. And we have a population standard deviation 3.5. And we have a z-value of negative 1.84. And we have a sample size which is equal to 40. And we want to find the p-value. So let me go back over to the air server. So I've already set all this up. All right. Now, what you should start thinking here is this along with this tell us that we're going to make our calculations using a normal distribution, mean 0, standard deviation 1, because we have z-scores instead of t-scores. It gets a little more complicated in this situation because when we have a not equal to test, then we have to separate our reject region into 2 equal tails. So whatever happens, we know we're going to have to multiply the answer we get initially for using our calculator by 2. Now the next thing comes, what tail do we do our calculations in? Well, that's all dictated by the sign of the test statistic. Since this one is negative, it means we're going to do our calculations in the negative tail. So we're going to run from negative infinity up to negative 1.84, but then we're going to have to multiply by 2 to account for the similar area in the other tail. All right, so guys, go to the calculator, go second function distribution. But this time we're going to use normal CDF because we have a z distribution. So I need to come negative E99. Negative 1.84. Comma 0, comma 1. And remember, gang, we got to multiply this by 2 because we do a two-tail test. So the correct answer is 0.065, 0.0658. So I'm going to go back to the test or the quiz and find the answer that's closest to 0.0658. Guys, clearly it's C. So C is the correct answer. All right, gang, moving right along. Now, this next question, again, pay attention to the detail here. We've got information we're going to use for multiple problems. So the first question says, use this information to find the confidence interval. And gang, right there is a percentage. So we're ultimately looking at finding the percentage of I guess, those in the state. What are we doing? A statewide survey concerning a proposal to raise taxes. So we're looking at the percentage of registered voters who would vote to raise taxes. Our sample is 580 out of 1,200. But that's just a sample. We're trying to generalize this to the population, which is P. So we're going to use a confidence interval for that. So first thing I'm going to do is I'm going to go to the iPad, and I'm going to write some information out. So I have the P hat is 580 out of 1,200. And I want to do a 95% confidence interval. So go back over, and this is what I've got. Well, since I'm dealing with a proportion, I know I'm going to use a 1 prop z. And a lot of you in class were using a 1 prop z test, which really doesn't make much sense considering you're wanting an interval. So guys, I'm going to go to the calculator and do a 1 prop z interval. Takes a while to get there. Again, don't get sloppy. Don't choose a test because that's not what you need here. The problem clearly states what is the margin of error for a 95% confidence interval. So this is what we got to do, okay? So let's go in there. X is the number on top of the the p hat. So in this case, it would be 580. Our total sample size is 1,200. We have a 95% confidence interval, and now we're going to calculate. Now, this interval is going to run from 45.5% to 51.1%. The easiest way to find the margin of error is to put this into percentage, so 51.1 minus 45.5 divided by 2 gives us 2.8. So our margin of error is going to be plus or minus 2.8. So let's go back to the quiz, find that. What did I do here? Let's see. 51.145, is that what it was? So 51.2 and 45.5. So 51.2 minus 45.5. So first mistake ever, guys. So here we get 2.85. So I just made a typo. So guys, go back to your quiz. 2.85. So the answer is clearly B. Now the second thing, what's the value for p hat? Well, that's really easy because that's just x over n, and that's 580 over 1,200. So I'm just going to go to the calculator and do 580 divided by 1,200, and so I'm looking for something close to 0.483. And that's clearly the closest thing to that is question A. Or I'm sorry, selection. I don't know why I keep saying question. All right, gang, last problem. We've got to go back up and kind of pay attention to what's going on here. They would like to ultimately test. This up here dealt with the confidence interval, but now we're actually getting into the focus here, which is to test the claim that the majority, guys, clearly majority is more than 50%, prefer to raise taxes. Now guys, before you start getting all crazy and stuff and start punching buttons in your calculator and getting an answer that you have absolutely no clue what it means, we have got to set this problem up. So the problem will be set up with the null hypothesis, p equal 0.50, and the alternative hypothesis, p, the majority, being greater than 0.50. And I'm pretty sure that the level of significance was 0.05. Okay? So the next thing we're going to do is we've got to get our test statistic. Now, some of you are telling me that you prefer to write all this out and do it the long way. I just don't understand that. I'm just going to be very candid, open, and honest with you there. When you've got the opportunity, use your calculator because it's just easier, it's quicker, and you're not going to make the calculation errors as easily. So, gang, I'm going to do that. So I'm going to go to Stat, and we'll go over to Test, and I'm going to come down to number 5. So my P0 is 0.5. And this is a good question because it's going to be very similar to the things you're going to encounter on your final exam. So we have our sample 580, 1200. It imported that in from the confidence interval. And come down and make sure that the alternative hypothesis is set correctly, and turns out in this case it is. So now we come down and calculate. Now, this is the type of thing that you're going to be doing again on your final exam. So we come in, and it's a little bit confusing because for all the P's that we have. First of all, we have P up here, which is the population proportion. Then the calculator comes down here and gives you another P, which is indicated or implied to be your P-value, and then you've got a P-hat. Well, gang, it's just part of learning statistics. You've got to keep the notation separate. But nevertheless, guys, right under our test statistic will always be our p-value, which is what is needed to make our decision. So our p-value is 0.88. Which is clearly bigger than our alpha of 0.05. So guys, our decision here is clearly failed to reject H sub O. Now, failed to reject H sub O says that of the two statements, based on our sample, this one is most believable. That the percentage is equal to 50%. Not greater than 50%, not less than 50%, but at the end of this problem, we can conclude nothing more than our best estimate is it is 50%. So guys, come in. Now, let me just use this kind of as a teaching opportunity. What if our p-value had been like 0.02? So if this p-value right here had been 0.02, then we would have gone over here, and again, just what if, it's not the case in this problem, but just what if this was a 0.02, then that would have been less than our 0.05, and we would have rejected H sub O. Rejecting H sub O would have been, we reject that statement, this is more believable. So we would go back to our test, and instead of doing, selecting A as we did in this case, we would select this. So guys, this is just an indication of how when you take your test, next Thursday, it's going to be so tempting when you get a problem like this, the very first thing you do is pick up that calculator and start punching buttons. But guys, you got to get this set up. You've got to get your null and your alternative hypothesis set up. So once you make your reject or fail to reject decision, you'll know which one of these statements is, quote unquote, most believable, I guess you would say. All right? So that's the kinds of things you're going to be doing next week. So let me shut this down. That was actually pretty fast and pretty painless. So I guess that's it, right? We've yeah. So guys, have a happy Thanksgiving, and see you next week.